Hello and welcome to this solution video of Mechanics 1 paper 41 summer 23. If you like this video, please give it a thumbs up, share with your friends and subscribe to my channel. I'll be making many more videos like this for you in future too. Let's start with question number 1. The particles P and Q of masses m kg and 0.3 kg respectively are at rest on a smooth, okay, that means there is no friction, no resistance, horizontal plane. So this is smooth plane, this is one particle, this is another particle, this is P and this is Q. P is projected at a speed of 5 meters per second towards Q. So it is projected like from a catapult or like a bullet, or maybe it is pushed. I mean, not pushed means it was just kicked. There is no force after that. After P and Q collide, P moves with a speed of 2 meters per second in the same direction. P keeps on moving. Obviously, if it keeps on moving, Q will also be moving in this direction as it was originally moving. So it was moving in this direction. Both P and Q start moving here. Find in terms of m the speed of Q after the collision. So since it's a collision and there is a smooth plane, we can use conservation of momentum. Okay, so what does conservation of momentum means? It says mass of the first one, velocity of the first one multiplied, rather we'll say the u1, okay, initial velocity, and m2 u2, mass and initial velocity of the second one, is equal to mass and final velocity of first plus mass of second particle multiplied by the velocity of the second particle. Okay, m1 P is m kg, so it will remain m. u1, initial velocity, it was projected by 5 meters per second, so 5 plus, since Q is at rest, it was both of them are at rest, but only P was projected, so that means Q is at rest still. So 0.3 is the mass, but speed is 0, and then m1 is again m, and it moves 2 meters per second in same direction. So this was positive, this will remain positive. Then we have m2, which is 0.3, but we do not know its velocity. And this is the velocity they are saying. Find in terms of m the speed of Q. Speed of Q is this one, so we have to isolate this one. So let's bring this 2m to the left side. So it was 5m. We get 2m from this side, and then this is 0. We will not even consider it. Is equal to 0.3 v2. So 5m minus 2m is 3m, equal to 0.3 v2, divide both sides by 0.3. So v2, because this cancels, v2 stays here and it comes out to be 3 divided by 0.3 is 10 m. So the velocity of Q in terms of m is 10 m. Okay. After this collision, the Q moves directly towards the third particle R. Okay, so this is P moving at 2 meters per second. This is Q moving at 10 m meters per second. And then we have third one, R. It will go obviously there and hit this R. Okay. Of mass 0.6 kg, the mass is 0.6. This was 0.3. And this was unknown m, okay, which is at rest on the plane. So initial velocity of this u3 is 0. Q is brought to rest in the collision. When Q hits R, it stops. Okay, so we can say the v3 is 0. Okay, also not v3, v2 is 0. And R begins to move with a speed of 1.5 meter per second. So V3 is 1.5 meter per second. Since Q came to rest, R cannot go to the left. That means obviously it is also going in the same direction. They have not told us, but practically we can easily, common sense we can use. Find the value of M. Okay. So same thing. In this case now it will be M2 U2 plus M3 U3 equal to M2 V2 plus M3 V3, and we will not use U and V for mass 2, which is Q, what we used in the previous one. It is a new one. Okay, so mass is still 0.3, but U2 is after the collision it was moving at 10 m, so we will use 10 m in place of U2. This V2 becomes U2, so 10 m. Then M3 is at rest. Its mass is 0.6, but speed is 0. M2 after collision is at rest, so 0.3, but it comes at rest. Plus M3 is 0.6 and it moves with 1.5 meters per second, and simply we have to find M here. So 10 times 0.3 will be 3m equal to, this is 0, this is 0, so equal to 0.6 times 1.5 will be 0.9, and m will be 0.9 divided by 3, 0.3 kilogram. This was the mass of the particle P. And I hope we have finished question number 1. Let's go to question number 2. A particle P of mass 0.4 kg is projected vertically upwards. So let me try to visualize. If you notice, every time I draw something, because it helps us to plan our solution. So mass is 0.4 kg and it was projected upwards from horizontal ground. So this is ground with a speed of 10 meter per second. So U is 10 meters per second. Find the greatest height above the ground it reached by P. This particle P, it will go up, stop and fall down. They're asking it, what is this greatest height? What is the displacement from this height from the ground? And this is what we're going to do now. We will use the formula, which is V square equal to U square plus 2as. We know that it stops at this place. The velocity is 0. From here to here I want. Here I know that V is 0. So 0 square equal to U square given to us 10 meters per second. So 10 square plus 2 times gravity will be moving downwards. Acceleration due to gravity is always downwards. Since U is upwards, we will take this G, which is A in this case, equal to minus 10 meter per second square. So we'll write it here. And S is S. S will be the height it attains. So this will be minus 20s, which I'll bring it to the left side. So it becomes 20s equal to 100. S will be 100 divided by 20, which comes out to be 5 meters. Just meters, not meters per second. Okay. Now it has another part, which is part B. When P reaches the ground again, so if it reaches the ground again here, so let me redraw this in different place. So it goes up 5 meters, comes down and reaches the ground. When it reaches the ground again, it bounces vertically upwards, so it will bounce again. Okay. At the first instant that it hits the ground, P loses 7.2 joules of energy. So it came down with some energy, and whatever energy it went up with was 7.2 lesser. That's what it is losing 7.2 joules of energy, which will go to the ground. Okay. law of conservation of energy. Find the time between the first and second instant at which P hits the ground. That means it will go and hit again second time. So it was projected. We will not call this as hitting the ground. Hitting the ground, first one is this one, second is this one. So they're saying find the time between the first and second. That means how much time it takes from here to reach here. Okay. For that, what will I do? First, I will see what was the energy at this height, which was 5 meters high. Okay. So the energy at let's say maximum point, let's call it m, at m, equal to, it will be potential energy plus kinetic energy, right? And because there is no velocity here, v is a 0, that's what we said, it stopped there. So that means there will be no kinetic energy because v is 0. Only potential energy will be there, which will be mass of this particle was 0.4 kg. The acceleration due to gravity is 10 because energy is not a vector, so we will take it 10 as 10, not minus 10. Height it attained was 5. So it came out to be how much? 50 times 0.4, 20 joules. So it had energy equal to 20 joules here. There is no resistance here or nothing else. The energy, there is no reason why this energy will be lost while falling down. That means 20 joules of energy will reach here as well. At this point, when it hits the ground, the energy remains same, 20 joules. Okay, but after impact, first impact, let's call it first impact, what will be the energy? 20 joule was already there and it lost 7.2 joules of energy. That's what they're saying, which brings it to 20 minus 7 is 13, so 12.8 joules. We will find the energy which is here, it is going up, same energy will be here, which is 12.8 joules, same energy, right? And when it hits the ground second time, again the energy will be 12.8. There is no loss of energy from this point to this point. So what will I do? I will find what was the velocity here when it started going up. Okay, so because at this particular point at the ground, mgh is 0 because there is no height. So energy at after the first impact, which is 12.8, right? After impact, which is first impact, okay, equal to 12.8, which will be equal to half mv square, right? Whole of it will be kinetic energy, and I can cross multiply this, it becomes 25.6 equal to m is 0.4 and v square will be v square. So I divide 0.4 both sides. What do I get? 0.4 and 0.4 cancel, and this decimal cancel. 256 divided by 4, which is 64. Please use your calculator if you're not comfortable with mental math. So we'll square root both sides. V comes out to be 8 meter per second. Okay, the 8 meter per second is the velocity with which it starts going up and it will reach and come down. Now the question was, we want to find the time between these two impacts. Okay, if you look carefully, what is the displacement from first impact to second impact? Displacement is 0. Yeah, because it is ground, it started at the ground, ended at the ground. That means displacement is 0. What is u? We just found out u is 8 meters per second. This is the velocity with which it is starting after first impact, and we want to find time. So we know that s equal to ut plus half 8 square, right? S is 0, U is 8, time we want to find out, plus half. A, in this case 8 is upwards, but acceleration due to gravity is downwards. So U is upwards plus 8, A is negative minus 10 t square, and we have to find this solution here. So we can take what? This 2 and this 10 can cancel. We are left with minus 5t square. Let's bring everything to the left side. 5t square, this comes here, becomes positive, and 8t becomes negative. Why didn't I cancel them, putting them on across equal mark? Because I wanted two answers. It will give me two answers. T is common, that is first. That will give us me the first one, and then next we have 5t minus 8. So the first time t is equal to 0, which is correct. At the starting of this journey, t equal to 0, we had displacement 0. So this is already known. This is not our answer. This will give us the answer, which is 5t minus 8 equal to 0, 5t equal to 8. So t is 8 divided by 5, which is 1.6 seconds. This is the time between first impact and second impact. Okay. Let's move on to the next question, which is this. A particle moves in a straight line starting from rest. The displacement s meters of the particle from a fixed point O on the line at the time t seconds is given by. So this is fixed point O from where it starts. So whenever we have such a situation, we should start with writing that at t equal to 0, displacement equal to 0, because it is here at the starting point. So no displacement here. This is the straight line. Find the value of s, which is this, when the particle is again at rest. So it is starting from rest. That means this is v equal to 0. Now they are saying somewhere here in the line it is again v equal to 0. They are asking us what is the value of s, what is the displacement till that second point. Okay, so we could have easily done that by putting the value of t, but the problem is we don't know t. So to know t, we have to find at what times it is at rest, and at rest means the velocity is 0. So we will convert this s equation into v equation by differentiating it. ds over dt is v, which will be the differentiation of this part also. So differentiation of t to the power 5 over 2 will be 5 over 2 becomes coefficient, and the exponent goes down by 1. Minus 15 over 4 is already there. 3 over 2 will also come and become coefficient, and this will be 3 over 2 minus 1. And then differentiation of 6 is 0. It's a constant. Differentiation of constant is 0. Okay, so v equal to 5 over 2 t to the power 3 over 2 minus 45 over 8 t to the power half. This is the one. Now we said that at rest they are asking, so velocity has to be equal to 0. This has to be equal to 0. And this will again give us two answers like previous question. Like this question, we factored it and we gave it 2 times. And obviously one of the times will be 0, because they are saying that at t equal to 0, v is 0. So we will ignore that one. So how do we factor this one? We always look at the smaller power. Which is the smaller power? This is smaller power. Take this out. Also out of these two, which one seems to be smaller number, smaller, which can be factored into the other? So this 5 over 2 is the smaller one. So let's see what is remaining. 5 over 2 is out. Out of t 3 over 2, t half is out. So we will say 3 over 2 minus 1 over 2, because exponents subtract when they divide. So I'll divide this by this so that I get the remaining part, which is 1. So we'll be remaining here with t. Minus, out of 45, 5 is out, so 9 on top. Then out of 8, 2 is out, so 4 is here left. And this is already out, so nothing is left, equal to 0. So either this can't be 0, 5 over 2 can't be 0, so it will be t to the power half equal to 0. If I square both sides, it gives me t equal to 0, which is true, already known to us, so of no use. This will give us the right answer. T minus 9 over 4 equal to 0. T is equal to 9 over 4 or 2.25 seconds. This is the second time when the velocity is 0. This is the time they're asking for s. So what will we do? In this equation, we'll just substitute the time now. So s is equal to 2.25 to the power 5 over 2 minus 15 over 4, 2.25 over 3 over 2 plus 6. You can straight away put this in a calculator. Let me try. Square root of 2.25 is 1.5. It will become power 5 because 1 over 2 of this is square root, so which is 1.5 to the power 5 minus, let me also divide this, 7.5, so half is 3.75 and 2.25 to the power 3 plus 6. Just put all of this in your calculator and you will get your answer. By the time I do this, I request you to subscribe to this channel, like this video, share with your friends. It will motivate me to make many more videos like this. What I got is 15 over 16 or 0.9375, so let's 938 meters. This was the displacement when it stopped second time. Question number 4. The velocity of a particle at t seconds after leaving a fixed point O. So it is leaving fixed point O here. Mind it, this is VT graph, okay? So this is not like it is moving, this is showing the movement, no. It is showing that it is going in the positive direction, that's it. And because this line is straight, it's a constant acceleration. The diagram shows velocity time graph, which models the motion of the particle. The graph consists of 5 straight segments. You can count them, 1, 2, 3, 4, and 5. The particle accelerates to a speed of 0.9 meter per second. We can see that because gradient of a VT graph is acceleration. In a period 3 seconds, okay, then it's constant velocity after that. Then it decelerates, becomes stationary. Then it changes its direction. Again starts moving faster, faster, faster in opposite directions, and here it does not stop, it decelerates, right? That's what it means, right? In negative direction, it did not stop here, it stopped increasing the speed and started decreasing, and then it came back to rest at the same position because they said at O again. So this is same position, not because of the graph, because they have stated here. Okay. Part A, find the distance traveled by the particle in first 10 seconds. These 10 seconds, that means from a VT graph, if you want to find the distance, just find the area under the graph. And 10 seconds, we have everything. It's a trapezium, right? So area of trapezium is the distance covered. And it is in same direction, so no issues. What is the area of a trapezium? Half first parallel line plus second parallel line times height. So in this case, it is first parallel line is 0 to 10 seconds, plus B. Second parallel line is this, from 3 to 9, which is 6. And height between them, this distance between them is 0.9. This can cancel with this. 10 plus 6 is 16, so it will cancel this 8. 8 times 0.9 will be 7.2 meters. This was the displacement or distance covered from 0 to 10 seconds. B part. Given that t is equal to 12, so this is 12 seconds. Okay, I don't know why they gave it then. Find the minimum velocity of the particle. Minimum velocity is actually 0, but we will not count it at minimum because we have negative velocity also. We'll count this as negative as the minimum. This is minimum somewhere here, velocity. Okay, and how can we find this? Because it is coming back to the original point O. That means whatever distance it went away in one direction, same it came back. That means the area of this triangle will be exactly equal to the 7.2 meters, because the reverse opposite direction, the distance is same as what it went forward. Here it changed direction, so we'll equate 7.2 with the area of the triangle, which is half base times height, and this height from here till here is the one they're asking, the minimum speed. So 7.2, we can cross multiply this, so it becomes 14.4 equal to base. Base, they said this is 12, so this base becomes 2, and 2 has already been taken care of, so h, and h equal to 14.4 divided by 2, which is coincidentally 7.2 again, but here it was meter, here it is meters per second, and we can say minus also because minimum we are using. Because height is 7.2, but because of this graph we have to write minus 7.2 meters per second is the minimum speed or velocity of this one. Okay, we can't use speed because it's negative, we'll use velocity. Okay, what next? C is also there. Given instead that the greatest speed of the particle is 3 meters per second, greatest, and this time they're using the word speed. Okay, so no, they are not asking us that this 0.9 is 3. They're saying that 3 is somewhere here, which is more than 0.9, and if we use the term speed, it will be more than 0.9. Okay. Find the value of t and hence find the average speed of the particle for the whole motion. First we'll find t when speed is 3 meters per second, right? 3 meters per second? Yes, 3 meters per second. That means the height here is 3 meters per second. So it will be somewhere here, this height. So the triangle is actually this now, this triangle. Okay, and this 12 is not known to us, we have to find t. Okay, so again we'll use the same thing, 7.2 meters in forward direction, 7.2 meters in backward direction. So let me do C part here. 7.2 will be equal to half, and base we don't know this time, and height we know because 3 meters per second. The height, this height we know, 3 meters per second. So cross multiply, base is equal to 7.2 times 2 divided by 3. 2 multiplied here, 3 divided. So 2.4 times 2, b is equal to 4.8 seconds. From here to here is 4.8 second base, right? But they asked the value of t, and t is for the whole time. So the t will be 10 seconds was already with us, 4.8 more, it becomes 14.8 seconds. That is the value of t. Okay, but there was another part to it. If you look at it, find the average speed, again speed, not this velocity, speed again. So how much total, what is speed? Rather average speed they're asking, right? Average speed for any motion in a straight line will be the total distance divided by the total time it covered. Distance was 7.2 forward plus 7.2 backwards. This was the total distance traveled. Time taken was how much? 14 point, how much we got? 8. Yes, 14.8 seconds. Total in this case was 14.8 seconds, so it becomes 14.4 divided by 14.8, which is almost 1. But if I use my calculator, I'll get a better one. This is 0.97297 ... But we have to round it up to 3 significant figures. It becomes 0.973 meters per second, you can say. Okay, let's move on to the C part. Okay, C part we just answered, so we'll go to the next question. Question number 5. Okay. 4 coplanar forces act at a point. The magnitude of the force are F newtons, 10, 50, 40 newtons. They have shown it here. Okay. Given that the forces are in equilibrium, find the value of F and the value of theta. So Cambridge never surprises us. This kind of question comes 100 times. So for finding the angle first and later F, we have to isolate F sine theta and F cos theta. This is what we have been doing. So let's compare the x direction first. This forces. So this F, its component in this direction will be F cos theta, because theta is with this line, so this will be cos. Similarly, 60 is with this line, so the component here will be 40 cos 60 degrees. And there's no other force which is inclined, but we have 10 newtons also in this direction. Since the forces are in equilibrium, that means the resultant in x direction is 0, which means the forces on left, which is 40 cos 60 degrees, will be equal to the two forces to the right. 10 Newton is straight in this direction. Then we have F cos theta. And our purpose was to isolate F cos theta. So isolate, keep it here, bring 10 here. So 40 cos 60 is half actually, minus this 10 equal to F cos theta. So this is 20. So 20 times 1, 20 minus 10, 10. So F cos theta is equal to 10. This becomes equation number 1. These forces are in equilibrium, so Ry will also be 0. The force downwards is 50, which will be equal to the forces in this direction. This was cos component of F. This will be F sine theta, and this also will have sine component here. So 40 sine 60. Okay, so it will be equal to F sine theta plus 40 sine 60. Sine 60 is square root 3 over 2. So I'll bring it here. So it becomes 50 minus 40 times square root 3 over 2. This can cancel here. So equal to F sine theta, which cannot be subtracted easily because it is just 50 and this is 20 square root 3. Please never think that 50 and 20 can subtract. 20 is multiplying with square root 3, so according to BODMAS they will multiply first, so we can't subtract. F sine theta, this is equation number 2. To convert it to tan theta so that we can get angle, equation number 2 will be divided by equation number 1. So right with the right, left with the left. So F sine theta, rather I have written left here, so divided by F cos theta. Let me do it here. So this is the right side, this is the left side, no problem. I will do the other one also, it is allowed. They are equal, no? I can change their places also. So sine theta, this one is equal to 50 minus 20 square root 3 divided by 10. F and F cancel. Sine over cos we know is tan theta, and that was the purpose of dividing, so that we get this number 50 minus 20 square root 3 over 10. So theta will be tan inverse 50 minus 20 square root 3 over 10 put this carefully in your calculator and you'll get your answer. Let me do it myself. By the time I do this, I will request you to like this video, give it a thumbs up, share with your friends, and subscribe to my channel. This will motivate me to make many more videos like this. What I'm getting here is 59.9324 and more digits, but we will round it out off to 59.9 degrees. Okay, but they asked both theta as well as f, and f we have not found. We can use this one to find f. It is easier, right? F cos 59.9, and actually I'll use the all digits from my calculator, equal to 10. So f equal to 10 divided by cos 59.9. Okay, it comes out to be 18.32753 dot dot dot, rounded off to 18.3. See, significant figures. This is the f and this is theta. Got it? Next one. Given instead that f is something something, so I'll have to look at this. So this is square root 2. F is 10 square root 2 and theta is 45 degrees. Find the direction and the exact magnitude of resultant force. So I will copy those forces again. 50 was downwards, 10 was this way. Now they said that f is 10, so f was in this direction with theta angle here. So let me do this. It was f, so it will become 10 square root 2 and this is 45 degrees. So this component here will be 10 square root 2 cos 45 degrees, right? And in this direction it will be 10 square root 2 sine 45 degrees. Here we had another force which was how much? 40? 40, and 60 degrees was the angle. Okay, this is 40 newtons. Angle is 60 degrees. So this becomes 40 cos 60 degree, which was earlier there also, and 40 sine 60 degrees. Now they are asking us to find the direction and exact magnitude. Exact means we can't give answer in decimals of the resultant force. So let's find resultant force in x direction first. Since there are two forces here, 10 Newton and this one, I will take this as positive. Hopefully they will be more, so it will be 10 plus 10 square root 2 cos 45 degrees minus, this is in opposite direction, so it will be minus 40 cos 60. Okay, so what is it? Rx become actually okay, let me do it here. 10 plus 10 square root 2, and cos 45 is 1 over square root 2. So this is square root 2 and this is square root 2 cancel. So 10 plus 10 is 20 minus 40 cos 60 is half. Wow. So it is 20 and minus 20, 0 newtons. Perfect. That means whatever answer we get will be in vertical direction. There will be no horizontal force remaining. So this will move in the upwards or downwards direction, not left or right. So they said find the direction. So we already found the direction. We'll see which one is more. Accordingly, we'll decide the direction. But exact magnitude is remaining now. So Ry resultant in y direction. And since there are two forces upwards, let's take them positive. 40 sine 60 and 10 square root 2 sine 45 degrees. minus 50. This will be the magnitude of the resultant force because horizontal is 0. So 40 sine 60. Sine 60 is square root 3 over 2 plus 10 square root 2, and this is again 1 over square root 2 minus 50. This cancels here. So 20 square root 3, and this cancel, plus 10, and 10 minus 50 will be minus 40. So 20 times 2 is 40, and square root 3 is less than 2. That means we are getting our answer in negative. So let's change it. So this is actually, we assumed that it'll go up, but it's coming out to be negative. So we assumed it is up, but if I change that direction, it will become down. So down is the direction, and this is the magnitude. So let me write here clearly, magnitude equal to 40 minus 20 square root 3, and the direction, I can't write down here actually because it is a coplanar force. It is not a vertical force, so I can't write down. I will write along 50 Newton force, which was downwards. This one, in this direction we will have, right? So along 50 Newton force, this is the direction. Okay, what next? Question number 6, which is about a ramp, inclined plane, twice on 2 directions. We have 2 masses. Okay, they're saying that given that 1, every time theta is printed as 1, if it is given that theta is equal to 60 degrees, this one, and BC is rough, this one, okay, and the coefficient of friction between Q and BC is 0.7, the particles are released from rest. Determine whether the particles move. Okay, just we have to write. So since this is 0.1 kg, this one 2 kg, its force in this direction, because its inclined plane will be 2, because this is the weight, 2 newtons. So its component in this direction will be 2 sine 60. And this will have a component, because theta is 60 they have given, so it will be 1 sine 60. Obviously this is heavier, so this will move upwards, this will go downwards. However, this BC surface is rough. That means since it is trying to move up, there will be a frictional force additionally downwards. So if these two forces are more than this force, rather it will try to move in this direction, but friction will join that force in that case. So we have to just compare whether this and this, these two are more than 2 sine 60 or not. So let's see, 2 sine 60 is how much? 2 times sine 60 is square root 3 over 2 again. So just square root 3. Okay. Now here will be sine 60 plus friction. Friction is, frictional force is mu times r. Mu is given as 0.7, and r is the contact force, which is perpendicular to the surface in this direction, equal to the force here, which is component of this 1 kg, 1 newton. So it will be 1 cos 60 degrees. So that is going to be the r, which is equal to 1 cos 60. So I'll write just cos 60, cos 60. So it will be 0.7 cos 60 in the other direction. So sine 60 is square root 3 over 2, and plus 0.7 cos 60 is half. So this minus this should be more than 0. So we will write 0 square root 3, this one, minus square root 3 over 2, this can cancel, 0.35 plus 0.35. 0.35. So square root 3 minus square root 3 over 2, half of it will be square root 3 over 2 minus 0.35. Okay, is it greater than 0? Let me do it mentally. You can check your calculator. So 1.73 is the value of this, divided by 2 will be 0.888 something 8. Okay, so it will be positive. 0.8 and 0.35, it is positive. It means the object, the particles are this thing, where the particles move. The particles will move because this force in this direction is more than two forces, these two combined, and that's why it will move in this direction. Okay. It is given instead that the BC is smooth. Oh, so there is no resistance in BC. So we have both the planes smooth now. There is no resistance. The particles are released from rest, and in the subsequent motion, the tension in the string which is going through this pulley is, it's not printed here, it is square root 3 minus 1 Newton. Okay, find the magnitude of acceleration of P, this one, and then find the value of theta. And what is theta? This is theta now, because in first part they gave us 60 degrees, but now it is unknown, we have to find it. This one is still fixed at 60 degrees. So let's focus on the particle P, which is being dragged here by its component of its weight, which is 2 sine 60. And it is being obstructed by tension. So we'll focus only on this, not the whole system. So what is the formula for that? In this case, it will be MA, which is net force on P. Let me write FP equal to MA, and it will be the difference of the two forces, 2 sine 60 minus T. So M is known to us, which is, how much is the mass of P? It was 0.2 kg. Acceleration we need to find out. 2 sine 60 is square root 3 over 2 minus tension is known to us, which is square root 3 minus 1 given to us, this one. So we can find acceleration now. 0.2a equal to, this cancels, square root 3 minus square root 3 plus 1. This minus changes both signs, they cancel out. 0.2a is equal to 1. A is 1 over 0.2, which is 5 meters per second square. We have to find theta now. So let's focus on Q. So Q is being pulled down by the force, which is 1 sine theta, right? And it is being brought up by tension, which is again the same tension as square root 3 minus 1. So we'll write square root 3 minus 1 minus 1 sine theta, which is sine theta only, will be equal to MA. M in this case is 0.1. Acceleration we just found out for both the particles, because they are connected, is 5 meters per second square. So let's bring sine theta here, it becomes positive, equal to square root 3 minus 1, and 0.1 times 5 will be 0.5 minus 0.5. So theta will be sine inverse square root 3 minus 1.5. That's what it is. So just put this in a calculator and you'll get your answer. By the time I do this, I would request you to give it a thumbs up this video, like it, share with your friends, and subscribe to my channel to motivate me to make many more videos like this. What I'm getting here is 13.41784 ... rounded off to 13.4 degrees. Okay, let's move on to the next question, number 7. A car of mass 1200 kg is traveling along a straight horizontal road, okay, this, and a car is moving on this straight road. The power of the car engine is constant and is equal to 16 kilowatts. So power is 16,000 watts. We can't use kilowatt. That means we have to convert it to watt, because watt is same as joules per second. That's why we need watts, not kilowatts. There is a constant resistance to the motion magnitude 500 newtons. So there is a force of resistance 500 Newton. Okay, then what do we find? The acceleration of the car at the instant when this speed, at the instant when the speed is 20 meters per second. So at a specific instant, if you want, it is power is equal to force applied by the engine and times speed. Power is known to us, 16,000 is equal to applied force, and velocity is 20. Divide both sides by 20 so that we find force applied, which will be 800 newtons. We want to find acceleration, right? So MA, net force, is equal to applied force minus resistive force. Mass is 1200 kg. Acceleration they're asking us to find at that instant when this was the speed 20. Applied force we just got 800 minus 500. So A will be 800 minus 500, 300 divided by 1200, which is 1/4, 0.25 meters per second square. Okay. Second part says, assuming that the power and resistance forces remain same. So the power is still 16,000 watts and force of resistance is still 500 newtons. Find the steady speed at which the car can travel. What steady speed means? That there is no acceleration. Acceleration is equal to 0. We said MA equal to F applied minus resistive force. Since acceleration is 0, this whole thing is 0. So 0 is equal to, or we can say that resistive force is same as applied force, which is 500 Newton in this case. Now, since they are asking speed, we'll use the same formula. Power equal to force and times speed, because it is steady and this is constant. That means that force applied will be constant. So power is 16,000 equal to force applied. Power always belongs to the engine, the applying force, okay, not anywhere else. So applied force is 800, no, not 800, 500, my apologies, 500, and this is the steady speed. Divide by 500 both sides, and it'll be 160 divided by 5, 32. Yeah, 32 meters per second is the steady speed. Okay. What next? Okay, we have something else, which is the car comes to the bottom of a straight hill. So if this is the hill and this was the straight, it came and reached here. Okay, 316 meters long. Okay, 316 meter is the length of this hill. Incline an angle to the horizontal of sine inverse 1/60. That was the angle, could not type it. So this angle is sine inverse 1/60. You should be aware that inverse is always the angle, okay, it's not the ratio. The power remains constant, so power is still the same. watt. Okay. Or the magnitude of the resistance force is now, no, it's not 60, is no longer constant and changes such that the work done against the resistance force is ascending. In ascending, the hill is this. So work done against the resistive force is 128,400. It is changing, huh? But total work done, that means from here till here, not an instant now, the whole journey, this is the total work done. Yeah, that the work done, they have not used the word total, but yeah, total work done from here to here is 128,400. The time taken to ascend the hill is 15 seconds. So time taken is 15 seconds. Okay. What else? Given that the car is traveling at a speed of 20 meters per second at the bottom, so U is 20 meters per second. At the bottom of the hill, find its speed at the top of the hill. What is V? That's the question. So since power and time is involved, we'll use the energy equation in this case. And first we'll have to find what is the work done by applied force. Yeah, because that is the formula. Work done by applied force is the sum of work done against resistive force plus change in kinetic energy plus change in potential energy. Yeah, so because the speed changed, we have a change in kinetic energy. Because the height changed, we have a change in potential energy. WR, work against resistance, is given to us. We have to find applied force with the help of power. Power is nothing but change in energy divided by time. Change in energy in this case is applied force. Work done by applied force, sorry, divided by time. So power is 16,000 equal to work applied we want to find out, so that we can plug it in our equation, divided by 15 seconds. So 15 times 16,000 will be 240, 123 joules. This is the work done by applied force, and now we have almost everything. We will just use them to find our answer. So work applied, we just got it 2, 4 and 1, 2, 3, 4 equal to 128,400 is the work done by against the resistance, and plus change in kinetic energy. Change in kinetic energy, the formula is half m final velocity minus initial velocity square. Okay, that's what I'm going to do here. So half m is 1200 for this. VF, they're asking us what is the final velocity. If you look here, they're asking us what is the final velocity. We don't know, but we know the initial velocity was at the bottom was 20 plus potential energy. The formula is mg final height minus initial height. What was the initial height? 0. It was started from the bottom of the hill, 0, but it gained this height. Let's call this height h, and we'll find it somewhere here. Oh, let me find it here only. H divided by 316 is sine theta. Yeah, opposite to this angle, opposite divided by hypotenuse is sine. And sine, if sine inverse 1 over 60 is theta, that means sine theta is 1 over 60. That's what it means, right? So we'll substitute this by 1 over 60 and multiply here. So h becomes 316 times 1 over 60. That's what we are going to use here. So I was here. Let me separate this. Okay. So it will be m, which is 1200, g, which is 10, and height difference will be this height minus 0, which is this height only, 316 multiplied by 1 over 60. So we can cancel this. It becomes 600. We can cancel this with this, 20, and that's it. Okay. So 24, let's continue here. 24, 1, 2, 3, 4, minus 128400. And this also, 20 times 10 is 200 times 613, so it will be 632 minus 632, 2 zeros, 1 0 from here, 1 0 from here. Okay, equal to 600 v square minus 20 square will be 400. Okay, let's open this bracket and try to solve this. So 240000 minus 128400 minus 63200 equal to 600 v square minus 24. Oh, it comes out to be exactly same number as this, but this is negative, so it will add up there. So 24 plus 24 becomes 48. 1 2 3 4. 128400 minus 63200 equal to 600 v square. This has already gone and become 48. Okay, what I get after subtracting this is 288 400 1 2 3, okay, equal to 600 v square. So divide both sides by 600. This cancels, these 0 also cancel, and then v will be square root 2884 over 6. Just put this in a calculator and you get your answer. What I'm getting here is 21.92411 rounded off to 21.9 meters per second. This was the speed at which it reached at the top of the hill. Okay, this concludes our exam 41. I hope you liked it. If you did, please give it a thumbs up, like this video, share with your friends, and subscribe to Math United. Thank you very much.